y is directly proportional to the square of x plus 3. When x equals 2, y equals 5, find y when x equals 1. Again, we have to establish the relationship between the variables. So y is directly proportional to the square of x plus 3. So it's directly proportional to x plus 3 all squared. We replace this proportionality sign with y equals k. So we have the proportionality constant k. Y equals k times x plus 3 all squared. In order to find y when x equals 1, we first need to find the value of the proportionality constant k. So we use the initial condition, x equals 2, and when y equals 5, to find k. So 5 equals k times 2 plus 3 all squared. 5 equals k times 5 squared. 5 equals 25k. Divide by 25, k is a fifth. So y equals a fifth times x plus 3 all squared. And now we can find y when x is 1. So y equals a fifth times 1 plus 3 all squared. A fifth times 4 squared, that will be 16 over 5. If you like, that is 3.2. But this is acceptable to leave it as 16 over 5. Y is inversely proportional to the cube root of x plus 5. When x equals 3, y equals 12. Find y when x is 22. Again, we first have to establish the relationship between the two variables. Y is inversely proportional, so that's indirect proportion, to the cube root of x plus 5. So it's proportional to 1 over the cube root of x plus 5. So it's the cube root of x plus 5. We can replace this proportionality sign with the proportionality constant. So y equals k over the cube root of x plus 5. We're now going to use the original or initial condition, x equals 3 when y equals 12, to find the value of k. So 12 equals k over the cube root of 3 plus 5. It's coming up here. 12 equals k over the cube root of 8. The cube root of 8 is 2. So 12 equals k over 2. Multiply both sides by 2. K equals 24. So y equals 24 over the cube root of x plus 5. And now we can evaluate the expression when x is 22. In other words, find y. So when x equals 22, y will be 24 over the cube root of 22 plus 5. That's going to be 24 over the cube root of 27. The cube root of 27 is 3, so it's 24 over 3, which is 8. M is inversely proportional to the square of t plus 2. M is 0.64 when t equals 3. Find m when t equals 8. Okay, first we establish the relationship between the two variables m and t. So m is inversely proportional to the square of t plus 2. So it's proportional to 1 over the square of t plus 2. So that's going to be t plus 2 all squared. We replace the proportionality sign with the proportionality constant, k. So m equals k over t plus 2 all squared. And now we use the initial condition to find the value of the proportionality constant k. So m equals 0.64. So 0.64 equals k over when t equals 3. 3 plus 2 all squared. 0.64 equals k over 3 plus 2 is 5. 5 squared is 25. Come up here. Multiply both sides by 25. So 0.64 times 25 is 16. So k equals 16. So the relationship is m equals 16 over t plus 2 all squared. Find m when t equals 8. So when t equals 8, m will be 16 over 8 plus 2 squared. That's going to be 16 over 8 plus 2 is 10. 10 squared is 100. Therefore, m equals, divide by 4. That'll be 4 over 25. Y is directly proportional to x minus 1 all squared. When x equals 4, y equals 3. Find y when x equals 7. Okay, so we first have to establish a relationship between the two variables. Directly proportional, y is directly proportional to x minus 1 all squared. So that's how we express direct proportion. This proportionality sign we replace with equals k. So y equals k times x minus 1 all squared. In order to find y when x equals 7, we first need to find the value of this proportionality constant. So to do that, we use the original or the initial condition, and that is x equals 4 when y equals 3. So 3 equals k times 4 minus 1 all squared. 3 equals k times 3 squared. 3 equals 9k. Divide both sides by 9. K equals a third. So therefore, the relationship is y equals a third times x minus 1 all squared. This is the relationship between y and x. Now we want to find y when x equals 7. So y equals a third times 7 minus 1 all squared. That's a third times 6 squared, 36 over 3. So y equals 12. M is inversely proportional to the square root of p. Explain what happens to the value of m when the value of p is multiplied by 9. So m is inversely proportional to the square root of p. So it's proportional to 1 over the square root of p. So that's how we are going to write. That's how we're going to express this relationship between m and p. We replace the proportionality constant with equals k. So m equals k over the square root of p. Now, what happens to m when the value of p is multiplied by 9? Okay, so when p is multiplied by 9, we get 9p. So m would equal k over the square root of 9p, which we're going to write as k over 3 root p, because the square root of 9p is the square root of 9 times the square root of p. Root 9 is 3, so it'll be 3 root p. So m equals k over 3 root p. Now, the original relationship is, this is the initial relationship between m and p. So we're going to highlight that in our new expression, which is just what I've highlighted there in pink. Now, what is the relationship between this expression here and that expression there? This expression is multiplied by a third to get that expression. M equals k over root p, m equals k over root p. We've essentially said k over root p times a third. If we multiply by a third, top times top and bottom times bottom. So we have multiplied by a third. So the value of m would be a third of its original value. Y is inversely proportional to the square root of x. When x equals 9, y equals 2. Find the value of y when x is 36. So y is proportional, or indirectly proportional rather, to the square root of x. This proportionality sign can be replaced with equals k. So y equals k over root x. Now x is 9 when y is 2. So 2 equals k over the square root of 9. In order to find the value of y when x is 36, we first need to know what the value of the proportionality constant is. So we take the proportionality sign, which looks like a fish, and we replace it with equals k. Use the initial condition to find the value of k, the proportionality constant. And once we know that, we can answer the question, find the value of y when x is 36. So 2 equals k over root 9, which is 3. So k equals 6. Therefore, y equals 6 over root x. And now we want to know the value of y when x is 36. So when x equals 36, y will be 6 over root 36. That's 6 over 6. So y equals 1. When x is increased by a factor of 4, the value of y changes by a factor of 2p. Find the value of p. We are going to use this equation, this relation between y and x, and we're going to manipulate it in such a way that we can find the value of p. So x is increased by a factor of 4. That means x is increased by a factor of 4. X becomes 4x. And the value of y changes by a factor of p. So y is increased by a factor of p, which means that the new quantity will be py. So we want to know what's going to happen by how much. We need to know the value of p such that the value of y changes by a factor of p when x is increased by a factor of 4. So what we're going to do is we're just going to put these two new values, quantities, into our expression. So y will become py and x will become 4x. So we will replace y with py and replace x with 4x. We're now just going to simplify this. So py equals 6 over the square root of 4 is 2. And then we have root x. So py equals 6 over root x. And I'll show you now why we're doing it like this, times a half. We look at this expression now. Instead of writing it as 1 over, instead of writing it as 3 over root x, we're going to leave the original form. We want this original form here. So keeping that original form, this over here, y equals 6 over root x, is this part over there. Now, we are essentially taking this y equals 6 over root x and multiplying both sides by the same quantity. By multiplying both sides by the same quantity, we're essentially not changing the value of the original expression, y equals 6 over root x. So what we've done, in essence, is we've multiplied the left-hand side by p and the right-hand side by a half. But in order for y equals 6 over root x to not change its value, p would have to be a half. So in other words, we would say a half times y equals 6 over root x times a half. We are applying the same operation on the left as we are on the right-hand side. So essentially, by doing that, we haven't changed the value of that expression there.